Hey everyone, welcome back. Ready for another deep dive?
Always ready to explore.
Today we're going quantum, folks. Quantum scars, ever heard of them?
Oh yeah, these things are fascinating.
Definitely a head scratcher, even for those of us who like to keep up with the sciencey stuff.
Right, it's like, where does chaos end and quantum weirdness begin?
And thankfully we've got this awesome article, Chaos and the Quantum Butterfly Effect, to guide us.
A great roadmap. So maybe we should start with chaos itself, just to get everyone on the same page. Butterfly effect, ring a bell.
Of course. Butterfly flaps its wings in one place, causes a hurricane halfway across the world.
Exactly. Tiny change, huge consequence. That's classical chaos.
Yeah,
Predictability goes right out the window.
makes weather forecasting a nightmare.
Oh, absolutely. But then we enter the quantum realm. Totally different rules of the game.
Right. It's all about probabilities, uncertainties, the whole shebang.
And that's where quantum mechanics comes in. It's a linear theory, which basically means probabilities don't go haywire like in classical chaos. So for a while there, physicists were like, okay, no chaos in the quantum world, case closed.
Seems logical enough.
Right. But then quantum scars, they kind of threw a wrench in the whole thing.
So what are these scars exactly? They sound kind of ominous.
Picture this. You've got a single particle, let's say an electron, trapped inside this tiny little stadium. In classical physics, that electron would be bouncing all over the place chaotically, completely unpredictable.
Right. Makes sense.
But in quantum mechanics, something really weird happens. The electron's probability distribution, where it's likely to be, it doesn't become a uniform blur.
It doesn't.
Nope. It forms these distinct patterns, like little regions, where the electron is way more likely to be found. And those, my friend, are the quantum scars.
Huh. So even in the quantum world, with all its uncertainty, there's still some kind of underlying order.
That's the fascinating part. It's not just random chaos. There's structure there.
And these scars are like, what, the fingerprints of that structure?
Exactly. They represent areas of higher probability within the electron's wave function. You can kind of think of the wave function like a map showing you where the electron is most likely to be, and the scars are like the hot spots on that map.
Okay, I think I'm starting to get it. But is this all theoretical, or did someone actually, see these scars?
Oh, they saw them, all right. Researchers use an electron scanning microscope and a sheet of graphene, that one atom-thick layer of carbon, to create a little confined space for electrons.
Clever.
Right. And guess what they saw? The quantum scar patterns, just as predicted.
Whoa, hold on. So this isn't just hypothetical. It's real observable stuff.
Absolutely. And that's where things get really exciting.
Mhm.
Suddenly, we're not just observing these patterns, we're thinking, okay, how can we use this?
Yeah, that's the big question. What are the implications here?
Well, think about it. We could potentially manipulate these seemingly chaotic quantum systems. Imagine being able to direct the flow of electricity or energy based on these patterns.
So we're talking like next level electronics.
Potentially. Smaller, faster, more efficient, maybe even superpowered graphene microchips.
And that would be a game changer. But I'm also curious about the bigger picture. You mentioned that this blurs the line between the quantum and classical worlds. What does that mean exactly?
Think about it. Quantum scars are this bridge between these two realms. They show us how quantum behavior, with all its strangeness, can actually transition into the more predictable classical phenomena we see in everyday life.
So it's like a peek behind the curtain of reality.
Yeah, kind of. And they could even shed light on some of the biggest mysteries in quantum mechanics, like the measurement problem.
Oh, right. That whole thing about how quantum systems seem to choose a state when we observe them always tripped me up. Could you break that down a little?
Okay, so imagine you've got a coin spinning in the air. Before it lands, it's both heads and tails at the same time. But the moment it lands, it has to choose one state, either heads or tails.
Right, got it.
The measurement problem tries to figure out how this choice happens in the quantum world. And quantum scars might just give us some clues.
So we're not just talking about cool tech here. We're talking about fundamental insights into how reality itself works.
Exactly. It's about pushing the boundaries of what we know.
Awesome. But before we wrap up, there's one thing I'm still a bit fuzzy on. When we talk about quantum chaos, is it the same kind of chaos as the butterfly effect? Like tiny changes, big consequences?
Not exactly. It's not about those huge cascading effects. Quantum chaos is more about behaviors within quantum systems that, in some ways, resemble classical chaos. It's a subtle but important distinction.
So chaos with a quantum twist.
You got it.
Okay, so to recap, quantum scars are these fascinating patterns that pop up in seemingly chaotic quantum systems. And they might just hold the key to revolutionary technology and help us unlock the deepest secrets of the universe.
And the coolest part, we're really just scratching the surface here. If these scars can emerge from what seems like random quantum behavior, imagine what other hidden patterns and order might be lurking out there in the quantum world.
Whoa, mind-blowing stuff. Definitely gives you a new perspective on things. Thanks for taking us on this deep dive. It's been amazing.
My pleasure. Always happy to dive into the quantum realm.
And to all our listeners out there, if this got your gears turning, definitely check out that article, Chaos and the Quantum Butterfly Effect. Who knows what other mind-bending concepts you'll uncover. Until next time, keep exploring.